Real quick, a review here. So far we've talked about 3 of the 4 primary conic types. Caitlin, which of those 3 is this?
Was it a Hyperbola?
Nope. So only one of the 3 conic types has only one of the 2 variables squared. So if you can't answer this, you have failed miserably to retain any information from this chapter, and nobody's given me an answer. So everybody is grossly unprepared for the test, every single one, unless you can answer this question. Incorrect. Ellipse has both x and y terms squared. That's the only one left. So yes, the parabola. By process of elimination, which will not work for you on the quiz or test, of course, this is a parabola. What are some characteristic things about a parabola we need to know? What did I ask you for in the quiz? That's one. Good job, Ian. What is the vertex in this case? Okay, good job. What's another characteristic of a parabola that I might concern myself with? The focus, yes. Not plural in this case. Focus is singular. And we determine the focus by having this in standard form. We get this. You see that the x is the squared term, so that tells us the orientation. And then the positive focal length tells us even more about the orientation. So Mackenzie, tell me, is this the vertical type or the horizontal type? Correct. And then based on the focal length being positive, does it go up or down? Correct. So this is an upward facing parabola. Do you see how that means for the focus, the parabola opens toward the focus? So that means we need to add this amount to the y value to get our focus. Now those formulas are there. You can consult them, but it's better if you understand it. -1 + 2 is +1. What else do we concern ourselves with regards to the parabola? Good. And remember, that's a line dead through the middle. For a vertical parabola, it's going to be x equals something. And it's whatever this x value is there. And then finally, what's the last thing we care about, Jesse? Starts with a D.
Matrix.
Correct. And I'll just abbreviate it DIR because that's a big, long, weird word. And that's going to be y equals something. And in this case, it is equidistant from the vertex as the focus. In other words, we add P to get the focus. We'll subtract P to get the directrix. So -1 - 2, -3. Welcome, sir.
Is today a good day?
Sure. Come on in.
Okay, give me a minute. I gotta get my stuff together.
Yeah, cool, man. Okay, so plot our points, and then we'll draw the parabola. So +2, -1, +2, +1, x equals 2. And then y equals -3. And remember, the parabola goes through the vertex towards the focus, away from the directrix. And I'm not really super concerned about the shape of the parabola. I know in Algebra 2 that was your primary concern. You know, you'd find 4 or 5 points and make sure the shape was accurate. But in this case, I'm concerned about those characteristics and is it pointing the right way? I really don't care that much about how accurate your analysis of the shape of the parabola is, as long as it's fundamentally the correction. Okay, so be able to tell what a conic is by looking at it, be able to find these characteristics. Now, I kind of spoon-fed you this on the quiz, because I told you what it was. But I reserve the right to not tell you what it is, and you just got to figure it out. So you never know if I'm going to go there. Okay, so here's another one. What type is this one? Can you tell by looking at it, Caitlin? Well, maybe, but because we got two things squared, that would make sense, and different coefficients, so that's a very good analysis. But do you see how it's harder to tell because it's in non-standard form? So it's very intelligent of you to infer it from this state, but most people would be challenged by that. So let's move it algebraically to standard form before we continue. Don't be late, guys. Got to change some things here. Present and present. Okay. So completing the square, we'll rewrite it down here. X squared plus 2y squared minus 4x minus 4y equals 2. This is actually a pretty good challenge because I need to rewrite this in such a way that allows me to complete the square. So Macy, I'm just going to write down what you tell me here.
Okay, x squared minus 4x blank 2y squared minus 4y.
Good. Don't forget your blanks. And then what?
Blank 2.
Good. So we've got a problem with the y. What do we have to do before we complete the square, Allie?
Squared.
So before we put a number in here, there's an algebraic step we have to do. Because this 2 is cramping our style. You can't complete the square until you factor out any coefficient on the squared term. X, we're good to go. Y, we're not. So what we're going to do, that's okay. Well, I knew you got it right on the quiz, so I assumed you did, but maybe your brain doesn't work before 9 a.m. You're not the only one in that situation, if that's the case. Okay, so you see how I factored it out of both these terms? This is a potential point of failure for you. So you don't just factor out from the y squared term. It's from the y term as well. And then you get this. Now let's complete the squares. Rowdy, what completes this square?
That one, we need 4.
Very good. And then Rachel, what about this one?
That one, you're going to get 1.
Excellent. Man, you guys are squared away on completing the square. So despite some other deficiencies, I'm happy with that. Now let's factor this. And then over here, we added 4 and then 1 times 2. So we actually added 6. You guys see why? So 4 and then 1 times 2. So we got 4 plus 2 or 6 we added in total. Meaning that constant term becomes an 8. So
you add them over, you have to subtract them over.
Well, because we added them to the left, we must add them to the right. So it's just balancing the equation. So don't subtract unless, well, you're never going to use a negative value in completing the square. It's impossible. So you would never subtract in this case. But it is, in other cases, when you have to balance the equation, it might be necessary, but never when completing the square. Riley, what does this first x term factor to? Very good. And then what about this one, Gracie?
Y minus 1.
Very good. Now, one more step is necessary before I can call this standard form. So Caitlin knew by looking at it, which is very impressive, but most of you guys will have to get to 2 into 8 is 4. most of you guys will have to get to this point before you can say, okay, that's an ellipse, and then start fiddling with it. But if you've got both things squared, it can only be a circle or an ellipse. And if they have different coefficients, it's automatically an ellipse. If you have different signs, it's going to be a new kind of conic that I'm going to show you today called the hyperbola. Yes, ma'am.
What did you say we can see in the letters?
Yeah, so from the, and this is, I would guess what Caitlin did. See how these are both squared? So that means circle or ellipse. And then see how they have different coefficients? Ellipse. If they have different signs, in other words, one positive and one negative, hyperbola. But anyway, moving it to standard form, it looks like this. So we've got now the same equation in standard form. So let's use that one instead. And now let's discuss those characteristics. So the type we've already determined is an ellipse. Tell me a characteristic of an ellipse we need to concern ourselves with. Yeah, focus is one. Well, there are two focus, and the plural for focus is what? So we'll just write them both at once, call it foci. And you know on that quiz, I had to check 2 boxes. So I had hoped that was clear, but I'd never used a quiz like that before. So I was kind of lenient for people that misunderstood that. Won't be able to do that for the test, because now you've seen it before. Now you know what to do, okay? What's another characteristic of a ellipse that we're concerned about, Bristol? Very good. What's another one, Jesse? Starts with a V. Well, there's 2 of them. There you go, vertices. And then what's the last one, Jan? Starts with a C, very similar to this. So that's what you put in your pie. Not the vertices, but the co-vertices is what I'm looking for. So again, if you can't name the characteristics, then I'm very skeptical that you'll be able to find them. All right, so make sure you're squared away on both of those skill sets. What is the center in this case, Colby? Good. And Rachel, can you look at this and tell me if this is elongated along the X or the Y? In other words, is it vertical or horizontal in its major axis? Very good. So this is the larger of the 2 denominators, meaning it is elongated along the X. Just a lot of little things to remember. Nothing's hard about conics, but it's about 100 little things like that you have to remember to make a good grade on this test. So we know it's elongated along the X, meaning the foci, we need our C value for it. C squared equals A squared minus B squared. So C squared equals 8 minus 4 or 4. C equals 2. And in this case, A equals the square root of 8, which is 2 on the square root of 2. And B equals 2. This is review, so I'm just going to go quick. Stop me if you're confused by something. And I need my little pen because that's just a little space. So we're going to say along the X, 2 plus or minus the focal length, which is 2, comma 1. And then for the vertices, we're also going to deviate along the x-axis because it's elongated along the x-axis. And that's 4 units. I'm sorry. A is the square root of 8, which is 2 on the square root of 2. So this is 2 plus or minus 2 on the square root of 2, comma 1. And you saw how I had to write it on the quiz with the SQRT and then parentheses. It's the only way that makes sense, I think. And then the co-vertices is 2, comma 1 plus or minus 2, like so. So it's an ellipse. That's how you find those characteristics. Questions? I haven't done a lot of review this year.
No, not on this. Can I use the restroom before we get started? Like, before
Yeah,
we
man.
get the whole lesson?
Yeah, man.
I just think
Routed down like a whole Starbucks or something.
I do every.
Plus, you got to hit that jewel pipe real quick.
Oh yeah.
Yo, dog, you got that blueberry pie? Just kidding. He doesn't do that. At least I hope not. All right, this one. Now notice both things squared. So thus far, the only two things I've showed you that's true for a circle and ellipse. We've already talked about a parabola. We already talked about an ellipse. So what do you think this one is? Good guess. It is indeed. So once again, you got to complete the square. But the thing about circles, you should have the same coefficient for both x squared and y squared. And lucky for us here, it's 1, so that just makes our life real easy. Mackenzie, what completes the square? Very good. Rachel, what about this one? Very good. And then what balances the equation? In other words, what do I need to add right here, Allie?
I understand that whenever there's one,
Uh-huh.
so do you just take the 2?
Well, if there's not a value outside the parentheses, you just add these two values together.
Okay.
So what is it in this case?
Okay.
Very good. It's okay. All right, so factorize. Jesse, what goes here? Excellent. Jan, what goes here? Excellent. So you take the square root of this, and then the sign from the middle term, and then the square root of this. So excellent. Now we got everything we need. So there's only 2 characteristics we concern ourselves with a circle, so we don't need those 4 boxes. Ian, what's the first of the 2 things we're concerned about with a circle? Good. What is the center in this case, Ian? Well, I agree with you as far as absolute value goes, but think about the sign. It's plus here. In the formula,
-2.
you're right. Okay, so the sign's different, meaning it is -2, and then what for the y? Excellent. And then what's the other characteristic we're concerned about with respect to circles? Indeed. And what is the radius in this case? Well, the radius squared is 25. Indeed. So radius is 5. Just feel free to sit down anywhere, Brian, or you can come here if you like. It might be a little more comfy. All right, so you guys had a quiz over this material. You've had a review over it. Today we're going to cover one additional conic, which is the hyperbola. And then tomorrow we'll cover a couple miscellaneous topics at the end of the chapter, which are not necessarily as closely related. So tomorrow is going to be skewed conics. In other words, we're going to take conics and shift them along an axis. You know, so far we've dealt only with perfectly horizontal or perfectly vertical conics. And tomorrow we're going to have ones that are skewed to the x and y axis. So that's a little algebraically intense. And then finally, parametric equations. Have you ever hit in the graphing functions, On your calculator, you notice it says a lot of weird things like POL and PAR and SEQ and all that. So I'm going to show you one of those, PAR, tomorrow. But for the purposes of today, we're going to talk about hyperbolas. Now, also, I have prepared a detailed, worked out key for the quiz that I'm going to release before the test. I'm going to attach it to the study guide for the test. But once I do that, nobody can turn the quiz in after that. So I'm giving all you stragglers one last chance to turn the quiz in before tomorrow. Or otherwise I can't accept, because I'm going to release the key with the study guide. And I think everybody in here turned it in, but still a couple that haven't in the other classes. All right, hyperbolas. Not to be confused with hyperbole, which is a literary device meaning to grossly exaggerate. We're going to analyze and graph equations of hyperbolas, and we're going to use equations to identify the different types of conic sections. Some definitions. So first of all, what is a hyperbola? What's a set of all points, and what's the term we use to stand in for that? Rachel. So there's a Latin word we like to use instead of the set of all points. What is it? Starts with an L.
Oh, that's right.
Think about I'll just go locus.
Yes.
I'm gonna give you a hint, but it would have made it too easy. I was gonna say sounds like focus, but then it would have been trivial. Locus such that the absolute value of the difference of the distances between two foci is a constant. And the absolute value part, normally you just say difference. You know, that's one of those parts of the definition that's sometimes present, sometimes is not. So the two things that a hyperbola has that the other conics do not have is what's called a transverse axis. And this is the line through the vertices. And it's analogous to the major axis of an ellipse. So a hyperbola, think about the shape. You see how it's an ellipse turned inside out? Because we've moved the foci outside the vertices. And so we sort of flipped it inside out. So it shares a lot of characteristics with the ellipse, and the transverse axis is analogous to the major axis of the ellipse. So those are related values. And then the conjugate axis is analogous to the minor axis of an ellipse. But you know, with a hyperbola, once we turn it inside out, the conjugate axis is not actually going to touch anything on the hyperbola. But it's through the center, perpendicular to the transverse. Remember, the upside down T means perpendicular to. Stop me if you have any questions, thoughts, comments. These are just definitions, just man.
On the definition of hyperbola, what does it say after distances?
That's between.
Oh, okay.
My little goofy shorthand for between. Sorry about that. Things make sense to my brain as I frantically write them. Sometimes they don't make sense to the wider world. Dan, what in the world kind of Coke is that?
It's the best color of vanilla.
Orange vanilla.
It's the
Interesting.
best color.
It's like a dreamsicle Coke.
Yeah.
Oh man, I gotta try that once I'm off my diet. Low carb. I spend most of my life on a low carb diet. It's the curse of middle age. You have to diet all the time, or you're in trouble. Okay, so once again, hyperbolas have two orientations, but the determination has nothing to do with the denominator. Okay, say that with me. The determination of the orientation has nothing to do with the denominator. Determination of the orientation has nothing to do with the denominator. It only concerns which of the two is negative. Remember I told you they'd have a different sign? So in this case, you see how the negative is in front of the y, and that makes it a left-right. Here the negative is in front of the x, that makes it an up-down. That's totally different from all the other conics. That's one of those little obscure, those 100 little things I said that you'll have to remember to get 100 on the test. So you must know that for a hyperbola, the terms will have different signs, and which one is negative determines the orientation. So if it's a negative y, it's left, right. If it's a negative x, it's up, down. And then you've got a bunch of formulas. They're all on that sheet I attached to the Chapter 7, Part 1 assignment. And they're on page 443 in your book. And I don't know if they did this on purpose, but all those formulas are exactly 10 pages apart in your book. So 443, 433, 423. So those are kind of convenient things if you're perusing that. Now, the asymptotes, those are these red lines. That's another characteristic that you have not yet encountered. You know what it is, but you haven't seen one with regard to a conic yet. So the asymptotes help us define the shape of the hyperbola. So we don't have a thing like a directrix that shows us what the shape is. We use instead what's called asymptotes. So this will be question 7 and 8 on the test. Question 7 will be a hyperbola that is already in standard form. Question 8 will be a hyperbola that's in non-standard form, and you got to complete the square. Those will be the two most challenging questions on the test. So that's going to be the bulwark between, most of you guys are going to be A's and B's because you're smart kids, you're great students. But that's going to be the difference between an A and a B. Can you knock out questions 7 and 8? Okay, so let's talk about one that's already in standard form. So the a squared and b squared, again, do not vary in this case. They don't. It's going to be always the a is under the positive term. So you see how it's whichever one is positive has a squared as its denominator. So if it's in standard form, it's always going to be the first one listed. So a squared equals 49 and a equals 7. And the b is going to be the denominator of the negative term. B squared, rather. Like so. So I've got a and b. Now you remember with the ellipse, c squared equaled a squared minus b squared. And I told you that was proprietary to the ellipse. Because with the hyperbola, c squared equals a squared plus b squared. Another one of those little 100 things you got to remember if you're going to make 100 on this test. So we have to remember that the formula for c is different for the hyperbola. And so in this case, c squared equals 7 plus, actually, sorry, 49 plus 81. So that's 130. Perfect square factors, I don't think so. Let me double check here. So 130 divided by 4, no. 130 divided by 9, nope. Now, once I get to 49, I need not go any further because if it's more than half of the value in question, couldn't possibly divide it. So we can stop our analysis here. There is no perfect square factor in 130, and so we just write it as radical 130. So we've got our C, our A, and our B, and we're ready to start filling in this stuff. Now, H and K, if we remember the formula in question here, remember it's x minus h. So what value is modifying x in this case? 0. There is no modifier. So that means 0, not 1, 0. So be conscious of that. And then you see the same is true for the y. There's no modifier. So the center in this case is the origin. That's a little shortcut. You may encounter one on a test like that. So don't get confused. If nothing is added or subtracted to x and y in this case, then the center is the origin. H and K are 0, 0. Now, the vertices, in this case, because, and this is the first flavor here because the x term is positive and the y term is negative. So we're going to go left, right, meaning the vertices will vary along that x-axis. So this is going to be 0 plus or minus a, comma, k. So 0 plus or minus 7, comma, k. And then the foci, go with a smaller pen here, are going to be 0 plus or minus c, radical 130, comma, k. All these formulas are on that page. You don't have to memorize them, but you do have to know how and where to apply them. So the classes of pre-calculus past had to memorize all this crap. Can you imagine? A student taught at Science Hill with Deidre Brown. She had her students not only memorize the formulas, but how to derive them for every mathematical entity in pre-calculus. Now, when I walked in her class as a student teacher many years ago, about 1/3 of the class had their head down. It's a huge class, 30 kids. 10 kids had their head down. Now, I didn't want to call her into question in front of students, so I waited till her planning period. And then I said, Ms. Brown, why did all those kids have their head down? And she said, well, they're all failing, so there's no way they can pass the class. I thought, wow, interesting teaching strategy. Or lack thereof. Nice lady, just old school. That's the way they did it in the old days. Sink or swim. Transverse axis, y equals k. So that's y equals 0. Conjugate axis, x equals h. In other words, x equals 0. Now the asymptotes, there are two. And it's going to be positive or negative here. So y minus k is y minus 0. And then plus or minus b over a. And that's different with the different orientations. It's a over b if the parabola is the hyperbola is the up-down type. So in this case, it's b over a, so that's 9 over 7, and then times x minus 0. So we can rewrite that as this. Give you guys a second to digest that, and then we'll analyze the graph. As always, let me know if you got a question, you don't know where something came from, confused by one of these values, how I derived it, or whatever. So as I said, this is going to be the bulwark, Gandalf on the bridge, in the Balrog in this analogy. Okay, so let's talk about the graph really quickly. Hopefully this will be somewhat legible. That's the graph of the same hyperbola we just discussed. You guys just look that over, see if it makes any sense to you. Values that don't make sense. Now we're off the graph with the foci, so that can be kind of weird. Because the square root of 130, I think the square root of 11 is 121, right? So 130 is going to be a little more than 11. So if we're deviating 11 point something from the center, you see how we'll land off of a standard 10 by 10 graph. So that's why you have those points outside the graph. The points are kind of haphazardly placed with respect to plotting the asymptotes and the transverse and the conjugate. So these dots are to help me understand that. Okay, any questions about the graph? Characteristics of a hyperbola? Thoughts or comments? Okay. So, let's see here. So here's one for you guys. You've got a little bit of a difference here. Notice which term is negative. See if you can analyze this and find all those characteristics. Raise your hand if you are confused, have trouble getting started, etc., etc. Also, don't mix up H and K. X is always attached to the H, and Y is always attached to the K. Doesn't matter which one comes first. I'll be a little hard to see. Let me see if I can give you a better view. A little bit better, I guess.
So for the A and B, D, is it always the second one, or is it D always the
A is always under the positive term. A squared.
Okay, so A squared is always,
Yeah, A squared is always the first one listed in standard form.
Okay.
The one that's positive. And that's another one of those little 100 things, right? Okay. Challenge you on this too. All right, so identify A squared. Which one is A squared? Yeah, so A squared is 64, let's say. Correct. So A equals 8, right, A equals. You gotta be like particular. And B squared equals what?
B squared equals 1.
So it's equals 7. You're gonna need access to those formulas. Because we just know them off the top of your head. So it might be good to bring your device. But you can find the center, the foci, the vertices pretty easily. Those other things you might need to consult a formula sheet. Don't get stuck on something. Phones up there?
No, you won't be talking about access.
Okay, we're starting first. Yeah, some people had some trouble last week, or the week before fall break, that kid walked out. One of the young ladies in my coding one class, walked out her DC schools account, she nearly had a panic attack. Give you guys a couple more minutes. Once you feel comfortable with your result, turn a glance at your neighbor's paper and see if they agree with you. Or in Jesse's case, you have to turn to an adjacent table. Yeah, that's good right there.
So it is still attached.
As far as this text is concerned, as far as your textbook is concerned, yes, but with these formulas, you need to use it this way. So Caitlin noticed on the formula sheet I attached, and I draw these from various sources. They switch the X and Y, and that's okay. Or sorry, they switch the A and B, and that's okay as long as you do it in all the formulas too. So if you're going to use the textbook, you need to do it the way I said. If you're going to use that handout, then you need to stay consistent with those formulas. So, I mean, that might sound a little confusing, but in essence, all you have to do is just use one resource. You can't draw a formula from two different places because you're going to run into some conflict. As long as you only use one or the other, you can do that. And the way I'm describing it here is the textbook way. Here. Yeah, exactly right. Yeah, the X is always attached to the Y. So that's right. Good job, buddy. Another 30 seconds or so, and I'll discuss your results. That was fast. Then our power break was water and grapes. Okay, so I'm going to put the answers up here, and I want you to take a moment and compare what you've got to what I've got, at whatever point you made it to. And again, this is using the textbook formulas. If you use the formulas from that handout, the A's and B's are inverted. But it's arbitrary, right? I can call a variable anything I want. I can call it smiley face or happy unicorn, whatever. I used to have a young lady in the differential equations class in college sat beside of me, and she was an artistic soul, and so she would use things like little drawings of a giraffe for her variables. You'd all ever saw her work looked insane, but she always was right. I was impressed. The moral of that story is you can use anything you want for a variable. It doesn't matter as long as you're consistent with it. As long as you use that same variable for every step. So again, make sure you do use either one resource or the other, not both. Don't mix and match. Okay, so any question about any of these characteristics? Sure. Uh-huh. If you leave it like that, that's fine, because the answers on the test I left in this form. Now you could of course move it to slope intercept if you want to, but the way I've got it on the test is in this format. So when you're comparing your answers, you know, those check boxes I made, it'll look like this. And be careful because, you know, based on your screen, if you try to do it on your phone, you're setting yourself up for a problem because some of them are across two lines and it's going to be really hard to see what the heck I'm doing. So I would use a computer for the test if I were you. Okay. Questions about anything? Thoughts or comments? All right, let's move on. Now, I told you there would be two types of hyperbola problems. First type, it's in standard form. And then the second type, it will not be. So, and I told you, number 7 and 8 will be the hardest problems on the test. This will be like number 8, and it will be the hardest. And traditionally, it requires the most work. Okay, so I'm going to rewrite this in a way that allows me to complete the square. And I'm going to let Rachel tell me what to write. Okay, take your time.
You take the square root of.
Say that again.
Sorry. You go line them up to 3x.
Oops, I'm in highlighter mode somehow. So 3x squared I agree with for the first term, then what? Good.
Minus 5. And minus 4. Wait, actually,
Yes, which we've barely left ourselves room to do, but yes. And now what? Very good. So these blanks are going to indicate places where we use values to complete the squares. But in both cases, we need to factor something out first. Anything in front of that squared term is going to cramp our style when we try to complete the square. Anything, even the minus sign. So we got to factor out the 3 here and the minus sign here. So let's do that. So I've got 3 times x squared minus 10x plus blank. And then factor out the minus sign from these. Y squared minus plus 4y plus blank. And then equals negative 48 plus blank. So tell me what to put in that first blank, that leftmost term right here, Jan. Well, take 1/2 of this and square it. So 1/2 of 10 is 5 squared is 5 times 5.
Oh. Oh, 5 squared. I was thinking square root.
Don't overthink it. Macy, what goes here? Very good. Now, this is tricky. So, Colby, what goes here? Very good. Good mental arithmetic, sir. 25 times 3 is 75. And then, well, there is one little boo-boo we made. But you use the right values, Colby. So that's 75, but then it should be minus 4. So 71 is what I'm looking for. But you had the right values, so you were 90% of the way to where you needed to be. 4 times negative 1 plus 25 times 3. Whatever's outside the parentheses, including just a minus sign, we have to multiply by the value to get what we actually added to the equation. That's super tricky. Easy to screw that up. Even a person that normally makes 100 on every test is subject to making an error right there. So be super careful. All right, so let's rewrite this. So this is going to look like this. Now, Gracie, tell me what goes right here.
X minus 5x.
Not 5x, just x minus 5. Remember, when we factor, the linear term's kind of built in. It will only, it's from outer times outer and inner times inner. You remember FOIL. So it's still there, but it's hidden. Riley, what goes right here? Very good. And then negative 48 plus 71, 23. Now this one's kind of nasty because we're going to have some weird, funky fractions in the denominator. But that happens sometimes. So it's good for you guys to see that. So, and the main culprit is this. Let's see that 23. That's going to really make this next step look weird. But, and I wouldn't throw you one like this on a test, but I do reserve the right to on homeworks and so on. So, because I think it's good practice. So writing in standard form, we look like this. See how weird that is? So unusual to have a compound fraction, but it is something you'll occasionally encounter. So let's find our A, our B, our C, our H, and our K. That's all we need to know to populate all those characteristics. So A squared is what, Caitlin?
Squared is
And we're using the textbook formula.
the square root of 23.
So that's A, but
Yeah,
for
so
A
it's
squared, it's just 23 over 3. That's okay. And then tell me what B squared is, Rachel. Say again? Very good. And then B is radical 23. And then C squared equals what in this case, Ian? Well, don't populate it yet. Just give me the formula. For hyperbolas, C squared equals blank, A squared plus B squared. Now, don't get it twisted, because remember, for ellipse, it's the difference. But for hyperbolas, it's the sum. So there's a minus sign in here when you do this for ellipses. Plus sign when you do it for hyperbolas. Again, one of those little 100 things you got to remember. A lot of details in this. So C squared equals 23 over 3 plus 23. So that's an unlike denominator. I need to rewrite that as 23 over 3 plus 23 times 3, which is 69 over 3. Number math teachers avoid, but it makes mischievous kids chuckle. So 23 plus 69, 80 plus 12, 92 over 3. Make sure I'm right here. And then that's not going to divide evenly. You know the way to tell if a number is divisible by 3? Really quick and easy. Sum the digits and see if that number is divisible by 3. So what's 9 plus 2? Is 11 divisible by 3? And so 92 is not. It's a real quick way to tell if you can divide by 3. Just a handy little tool to have. So C is going to be the square root of 92 over 3. So we got some messy stuff here. And then we're going to plug in A, B, C to those formulas. We need 2 more values before we continue, though. H and K should be pretty trivial. So tell me what H is in this case, rounded.
5.
Good. And what's K?
-2.
Very good. 5 and -2. Everybody see where you got that? Excellent work so far. Now we're ready to plug all this mess into our formulas here. I'll just drag that whole thing down where we've got the other data. Okay, so the center, of course, is going to be HK. The vertices, now this time we have a negative y term in our standard form. So we're going to deviate left-right like we did with that very first example. Meaning we need to add a to the x component. Stay with me, Jim. No meditation in pre-calculus. 5 plus or minus a is radical 23 over 3, comma, -2. Focus. 5 plus or minus radical 92 over 3, comma, -2. Transverse axis. Y equals -2. Conjugate axis. X equals 5. Asymptotes. Y minus a -2 or y plus 2 equals plus or minus b over a radical 23 divided by radical 23 over 3. We could rationalize and do some stuff there, but I'm not going to bother. Because again, in every case on the test, I just left it in this format. And then x minus h, so that's x minus 5. So even as ugly as that was, once you get A, B, and C, do you see how easy it is? Really, no reason to miss it unless you mix up the formulas for the ellipse and the hyperbola, or you do something like Caitlin and I discussed, where you draw from one sheet and then from another sheet, and there's a conflict in the way they set up the variables. Hyperbolas, Patrick. My favorite. That's not helpful. All right, and then once again, we'll take a look at the graph, which will be all these points. And of course, to graph them, you have to convert it to decimals and so on, because you're not just going to know what the square root of 23 over 3 is. You'll want to use a calculator to give yourself a good estimate. I didn't ask you to graph anything on the test, but it is a good way to understand the problem. It does something weird to my dots when I do this, but you guys can see the general shape. Got the center down here in Q4, opens to the left and right. So, any questions about anything we've done? Hold that. You guys masters of hyperbolas now. So, what are the conics we have discussed? What was the first one we discussed, Rowdy?
Parabola.
Correct. And remember, the characteristics of a parabola are the focus, vertex, directrix, axis of symmetry. Those are 4 things you have to know how to find. What's the next one we discussed, Colby? Ellipse. And the characteristics of an ellipse are center, foci, vertices, co-vertices. Remember, the formulas are a little different for the ellipse versus the other things. Bristol, what's another one that we discussed on the same day as the ellipse?
Circle.
Circle. And that's the easiest one. It's got 2 characteristics, the center and the radius. Should be a gimme. That's question 5 and 6 on the test. And then the one we discussed today, of course, is hyperbola. And your characteristics are all the things we just found for this problem. Everybody clear on all of that? So that's going to be the bulk of the test. Now, there will be one additional question on the test regarding eccentricity. E equals C over A, or the roundness of an ellipse. And you can also use eccentricity to describe the behavior of a hyperbola, although it's a little less intuitive. It's how round it would be if it were an ellipse, if that makes any sense to you. But anyway, so eccentricity of an ellipse is a question I'll ask you. I'm going to ask you to identify a conic using the discriminant, which is a topic we're just about to discuss before we wrap up today. And then a bonus question about what we're going to do tomorrow, which is skewed conics. Remember, conics that are not parallel or perpendicular to the x-axis. And then parametric graphing. So that will be a normal question. Those are all the things that are going to be on the test, which we've covered all but 2 at this point, and then the bonus part. So let's get to that. Finding a conic by the discriminant. So you've got a standard form for each subset of conic. Standard form for parabola, standard form for ellipse, standard form for a circle, standard form for a hyperbola. I showed you what those all look like. But then you've also got a standard form for all conics. And it's this. So this is the standard form for all conics. AX squared plus BXY plus CY squared, and so on. So using this, once you get it to this form, if you want, you can know its type by looking at a relationship between B squared and 4AC. So this B term, it's going to be 0 for everything except for a skewed conic. So it's very common for this to be 0, but maybe it won't be. So you take B squared minus 4AC. If it is negative and B equals 0 and A is equal to C, you got a circle. If it's negative and B is not equal to 0 or A is not equal to C, you got an ellipse. If it is equal to 0, you got a parabola. If it is greater than 0, you got a hyperbola. Okay? So this is going to be one of the test questions. Classify a conic using the discriminant. And I'll tell you quickly what page you'll find that on. give you that information. Page 447 is where this information is. Again, it will be a test question. Okay, so we copy this just to save us a little trouble. So let's identify one using the discriminant. So first of all, notice the B term is 0. Well, take it back. It's not a standard form yet, is it? So let's see. Let me copy that as well, I suppose. I assume they wouldn't throw one like that at us, but you never underestimate the authors of this textbook. They do a lot of devious stuff. Okay, so what I see is A equals 2. And then B, well, I've got X and B instead of X and Y, but that doesn't matter. It's whatever the two variables are. Where they're multiplied together is my B. And so B in this case equals 5. And I need C as well. So let's see here. C would be the V squared term in this case. So that's 1. Everybody with me? Okay, B squared minus 4AC is going to equal 25 minus 4 times 2 times 1, so minus 8. And that's going to be 17. Greater than 0, we've got a hyperbola. So this one is just going to be a matter of, and the one I'll give you on the test will already be in standard form, so you won't have to do that. And I'm going to use the X and Y instead of X and B, so the mix and matching part won't be as challenging. But once you find this value, you need to be able to determine which of these things it's consistent with. Stay with me, Jim. Meditation time will be at 3 p.m. Sir?
We only need the first 3 values of statement.
Yes. To identify the conic. Now, to find the other characteristics, of course, the other things are valid and important. But just to figure out what type it is, yes, you only need those first 3. A, B, and C. Good observation. Other thoughts or comments? All right, guys. So I declare Chapter 7, Part 3 complete. And your task is the following. Page 449, numbers 4, 5, 6, and 11. And as always, let me know if you get stuck on something. Stop my video.